So we're looking at ionic equations today. Now, when you hear ion, guys, you need to think about charges, positive, negative charges, right? So obviously it's you're gonna actually see the interactions between the positive and the negative charges inside of a chemical equation. Now, there are ions that are not going to change. They're gonna remain unchanged in terms of their state. So remember, you have 4 states of matter for equations: solids, liquids, gases, and aqueous solutions, or in valency across the equation. Those are what we call spectator ions. So if it's plain and simple. If it is the element is aqueous or solid or gas on one side, and it have one valency there, and then on the next side of the equation is the same thing, nothing had changed, they're called a spectator. They're not physically participating in the reaction. They're just there watching the reaction, hence the name spectator. If these are removed from your equation, you're going to get an ionic equation. So we have some steps to write an ionic equation. Step number 1, you need to write a balanced chemical equation for your reaction. Everybody here successfully knows how to do this by now. Step number 2, break your compounds down into ions. There is a table that I'm going to give you that's going to have all your elements, all your radicals, and their respective ions attached to it. Eliminate the ions that remain unchanged on both sides of an equation. In terms of, and see I put it in red, in terms of state and valency. Those 2 things are going to be very, very helpful in your writing of your ionic equations. Then you rewrite the equation with the ions remaining. It does only sound hard, but it's really, really, really easy. Note well that elements by themselves will have a valency of 0. Covalent compounds, those are compounds that are made up of non-metals only. They don't have ionic charges and it cannot be broken down into ions, right? So like water, H2O, carbon dioxide, CO2, ammonia, NH3, those are some examples. 2 ions that come from the same compound on the same side of the equation are actually rejoined in the final ionic equation. So let me put all of these rule business into play. So let's go with that. So the example, complete, balance, and write the following equation in an ionic form. So they gave me lead nitrate and they put in brackets AQ. Remember, AQ stands for aqueous. So that's an aqueous solutions. Aqueous solutions is when you have your solute dissolved in a solvent. So that is a liquid. Added on to NaCl, which is also an aqueous solution. So it's 2 mixtures that you're adding on to give me PbCl2, which is a solid, S is solid, and NaNO3, which is the aqueous solution. So we have a salt here being formed and an aqueous solution here. So step number 1 is to balance your equation. So I say, all right, I had 2 nitrates on this side. I put a 2 in front here to get the 2 nitrates here. That 2 is also going to apply to the Na. So I put that 2 there to balance the Na, right? And it also balances the Cl on either side. So I write my balance equation first. We clear with step 1?
Yes, miss.
All right. Renel, Jeremiah, Anaya, Kelly's, Kian. You guys good with that?
Yes, miss.
All right. Step number 2 is to express everybody or break the compounds down back into ions, right? Now let me show you something here. You see this table showing the cations and the anions. These are the tables that you're going to be using to get your charges. It has every single thing that you need here. So all my charges are coming out of these 2 tables. So when we are breaking the compound back into ions, each single one of the element or the radical that you have involved in the reaction, you have to write it in terms of their ion. So the first thing we're doing, we're splitting Pb and NO3. Then we split in Na and Cl, right? Then we split in PbCl and NaNO3. We cut in those things in half, right? So let's take the Pb first. Pb, when we go on to the table, Pb has a 2+ charge. All right, right. So Pb has a 2+ charge, so I put the plus on top there. Remember that whole compound was aqueous. So I take that aqueous and I put it underneath there, underneath the Pb. Are we all right with that?
Yes, miss.
Yeah, miss.
All right. Girls, are you all right with that?
Yes, miss.
Yes, miss.
Great. Now, in order to get lead nitrate, lead has to be added on to nitrate. So I put my addition sign. Now, when we have to break it into compounds, you need to remove all them brackets from there. So remember, there is a 2 outside the bracket here for nitrate. So that's where this 2 comes from. You put your NO3 here. When I go on to my table tells me that NO3 is negative. Remember, it's an aqueous solution, so we put that there. Many times, children forget to put these states and they land into issues when they are writing ionic equations. I need you to pay attention to make sure that you're putting back your states and putting your ions properly. So do we all understand how I got to this point here with Pb2NO3 and the charges and the states?
Yes.
Yes,
All
yes,
right.
miss.
Girls, are you all right with that?
Yes, miss.
Yes, miss.
All right, we go in again. Now this whole compound is added on to this. So I bring down this addition sign here. And let's go with Na. So it's 2Na according to the balance equation. So you bring down your 2Na. It's an aqueous solution, the entire compound. So I put my AQ here. Then I go on to my valency table. I find out, okay, Na is a positive, so I put positive. We go in with the Cl. Na has to be added on to Cl to give me NaCl. So I put an addition sign between the Na and the Cl. It's that 2 that's in front of the Na is also going to be applied to the Cl. So that's where this 2 comes from, underneath. Cl is also an aqueous solution as part of NaCl. So I bring back my AQ. I put it underneath. I go on to the valency table and I find out Cl is negative. So I put my negative sign there. Are we all right with that so far?
Yeah, miss.
Yes, miss.
Yes, miss.
Young ladies, are you all right with that?
Yes, miss.
All
Yes,
right,
miss.
Renel. All right, Anaya, Evangeline,
Yes,
only
miss.
let me know, right?
Yes, miss.
Now we coming across to the next side of the equation. We're splitting it again. Take your Pb. Remember, you're breaking it into your ions. So you bring your Pb down. So you bring Pb down here. In this case now, watch it. Pb is a solid. It forms PbCl2 on the side. So you need to put your solid underneath. Go to the valency table, realize that, all right, it's 2+. You put your 2+ on top here. Just skip. Right. So you take your, you have to put an addition sign because Pb added on to Cl is going to give you PbCl2, right? So you put your plus sign, you take your 2 from underneath, you put it next to it. You put your Cl. Cl is also a solid in this case. You put your solid sign underneath. Go on to the valency table. You see, all right, chlorine is negative. You put the negative sign there. Right? Now that is going to be added on to the 2NaNO3. You put your plus sign. Go with the Na first. Bring down your 2Na. It's AQ here. You bring down your AQ here. Na has a positive sign. It's added on to NO3. So you add. Remember that 2 is also going to be applied to the NO3. So you have to put that 2 underneath. You put your NO3, you put AQ, you go on your valency table, you see, all right, it's negative. So we express everybody in terms of ion. Are we all right with that so far?
Yes, miss.
Yes, miss.
All right. That's all right, Hakeem. Gills, we all right with that so far?
Yes, miss.
Right. Now at this point, what we need to look for is to get rid of the ions that are remaining unchanged on both sides of the equation in terms of state and valency. So let me start to look. PB on the reactant side is 2 plus aqueous. PB on the product side is 2 plus solid. So that have a change. So we can't touch lead. Let me go on to nitrate. On this reactant side is 2NO3 negative aqueous. On this side is 2NO3 aqueous, negative aqueous. So we say, aha, you a change, I cancel it out. Go again. 2NO3 positive aqueous, reactant side, product side, 2 Na positive aqueous. You say, aha, you are changing at all? All right. Get rid of you too. Check the chlorine, 2Cl, negative aqueous, 2Cl, negative solid. You changing, we can't touch you. So we say, all right. And the last step now is to rewrite the equation. Oops, hold on. To rewrite the equation with the ions that remain in. And what you end up with here, Pb2 plus, all right, added on to the 2Cl negative, gives me PbCl2 because that's the formula that you get on that side. Remember, these two ions join on the product side to become the compound, so you can join them. All right. Any questions with anybody for this? Or we all right with that so far? Okay so far? Yes.
Yes, miss. Yes, miss.
All righty, right. Let me try our next one now. Before I give you anything to take down. Right, so I have another one here. The PbCl, it would be neutral, Sanaya, because of the fact that they come across on the next side and they form the salt. Yes, it will be neutralized, right? So in this one, they want you to balance the following equation and write it in the ionic form. So we have MgS added on to H2SO4 aqueous to give me MgSO4 aqueous added on to H2. Let me double check to make sure it balanced. 1 magnesium, 1 magnesium. 2 hydrogens, 2 hydrogens. 1 SO4, 1 SO4. So step 1, your equation already balanced. You don't have to balance that. So we move down into step 2, where we express everybody in terms of their valencies. One of the exceptions that we had was if it is you see an element that has, it's by itself, the valency of that is 0. So we don't write down a charge there. And magnesium and hydrogen in this case, on either sides of the equation, they're by themselves. So you need to write them as themselves. So you bring back down the magnesium as is. You can't put a valency there because it's said in your rules. The valencies for elements by themselves are 0. Bring down your plus sign. We're breaking apart now that H2 and that SO4. Now I put the 2 underneath, but you could, the most ideal thing to do is to put the 2 next to it, right? So let me just scratch this out here. All right, then make your life easy when you're balancing that. So you have 2 H2 positive aqueous, right? Sulfate is 2 negative. It's added onto the sulfate to give you H2SO4. It's SO4 H2 negative, right? So you have that. Magnesium on this side now is in a compound. So now we're breaking down the magnesium sulfate. because it's in a compound, we could put the 2 plus, put the aqueous underneath because it's an aqueous solution, add it onto the sulfate, 2 negative aqueous, and that's added onto the hydrogen by itself. So now, for step number 3, we have to figure out who here not participating in the reaction. It's quite simple. Let's go with magnesium. Magnesium on this side, I know valency, and it's a solid. Magnesium on the product side, Mg2 plus aqueous. Can't touch them. It end up getting a change in its state and valency. Leave it. Hydrogen. Hydrogen on this side is 2H plus aqueous hydrogen on the product side, and no valency and have a change in state. Can't touch it either. Let me look at the sulfate. Sulfate on this side is SO4, 2 negative aqueous, and it actually remains the same. So you say, ah boy, we could get rid of you because you are remaining the same on either side of the equation. So we get rid of the sulfate. And now the last step is to write the equation with the remaining ions. Now your equation is Mg plus H2 positive aqueous gives me Mg added on to H2. We are right with that one?
Yes, miss.
Yeah, miss.
Any questions from anybody?
No, miss. Question.
No, miss.
All right. So I'll say this easy, you know, it is just look hard, but once we go through the steps and you follow these steps word for word, you'll be okay. So what we're gonna do is restart the meeting now, same ID, same password.